For this build you'll need a 9V battery clip connector, push button switch, some wire, a 2N222A transistor, a 22 kΩ resistor, and a copper coil. So admittedly I cheated a little bit with the copper coil because my original plan was to wind it around by hand, but it's actually quite difficult to do and you need a good 300 turns to make it work properly without any overlaps. So I ended up taking the copper coil from the Tesla Coil kit. So I've drawn up a sketch of what I'm going to make here alongside the circuit diagram to explain it. So this design is technically called a Slayer exciter circuit, and the way it works is slightly different from a Tesla coil, and I'll explain why. But oftentimes you'll see something like this being called a mini Tesla coil anyway. So the circuit is basically a resonant transformer, and you can see here we've got our primary coil and our secondary coil, and essentially we've got the same thing over here. So this relies on the principle that when a current is passed through a coil, then that induces a magnetic field through the coil. And without getting into too much detail, because of a principle in physics known as Lenz's law, this causes an opposing magnetic field to be created in the secondary coil, and that then causes a current to flow in the opposite direction through the secondary coil, and for this reason you want the coils to be wound in the same direction when you're assembling this. So in the circuit, when the switch is closed, the transistor gate is closed and current flows through the resistor and the primary coil. Now, current flowing through the primary coil then causes a countercurrent to be induced in the secondary coil. And this countercurrent causes the transistor to turn off, which then means the primary coil is no longer supplied, which means you can't have a current induced in the secondary coil. And if there's no current induced in the secondary coil, then there is no countercurrent that's induced, and that allows current back into the primary coil. And in this way, the cycle repeats and the circuit is continuously, rapidly oscillating by itself. And what this means is that the Slayer exciter circuit is self-regulating, unlike a Tesla coil where you have to manually tune the coils to match the resonant frequencies. So now that explanation's out of the way, let's get to building it. Okay, so you want to start by soldering the positive end of the battery clip to the switch. Next, you want to get your other wire and solder it to the other end of the switch. Now we're going to take our transistor and as you can see we have our collector, base and emitter pins. You can see them quite clearly. So you want to take the resistor and solder it to the base of the transistor. And I'm using a little bit of flux so you can get a better join. And you want to take the other end of the resistor and solder that to the side of the switch which you have the other wire attached to. Next, you want to take your negative battery wire and you want to solder that to the emitter of the transistor. So now you want to take one end of your copper wire from the coil and sand it to remove any insulation for a better connection and solder that to the base of the transistor. So I've just cut up an old plank of wood from a broken air hockey table, I think, but it's up to you. You can use whatever you want for your base. I just gotta say, please use clamps or a vise if you have one, because I don't, and I had to use bricks, and it was not easy to do. Okay, so now I've got my wooden base to put the whole thing on. I'm going to be using hot glue to glue down the copper coil to the base. So now you want to wrap your wire, which is going to serve the primary coil, at least 1 to 3 times if possible, depending on the length of your wire, around the coil, which is the secondary coil. And then you want to solder the free end of your wire to the collector of the transistor. So now just to finish off, I'm just going to glue down the transistor and the switch, just so it's more securely onto the base. You got to be careful though, sometimes when you have the build on for too long, the transistor can heat and that can melt the glue. You just want to make sure that you don't overload the circuit with too much power. And as you can see, it's able to light up our bulb nicely. Just a bit of bonus footage for you. This is one I made about a year ago, and after I just replaced the battery, I noticed you got this lovely blue glow to it, but I couldn't quite get any arcs out of it. There are some other variations as well, and some things you can do by increasing the number of coils or adding capacitors and diodes, do certain things to it to get more output, which I might do in the future, you know, if that's something that's requested. But that's it for this video, so if you've got any comments or suggestions, please leave them down below, and thanks for watching. Goodbye.